Hi, in this video we start the linked list implementation from scratch. So first of all, let's create a distinct class for the nodes in the linked list. It's going to have the class node with object. This is how we create a class in Python. And we are going to have a constructor. So we define the init method. Basically, this is how we represent the constructor in Python with a self and the data. Basically, whenever we instantiate a node, we are going to specify the data we would like to store in this node. So we just have to create this data accordingly, and there's going to be another feature of the given node. We are going to store a reference to a next node. It's going to be initialized to none at the beginning. Okay, so that's all about the node. As we have discussed in the theoretical section, every node is going to store the data itself and going to store a reference to the next node. This is how we construct linked list. Then we have the linked list class with the object. Okay, we have the init constructor with the self. And basically we are going to create the head of the linked list. Basically it's going to be the first node in the linked list. Okay, and we have the first.size, which is going to be initialized to be 0. So it's very important that it is like a tree-like structure. We are going to talk about trees. We are able to access the root node of the tree. It is the same for the linked list. We are not able to access the middle node directly or the last node. We are able to access the first node, which is called the head. And we are able to access other nodes with the help of this next node reference. Okay, so that's all about the head and the size. And we are going to have a method, for example, insert start. It's going to insert some data at the beginning of the list. So first of all, we have to increment the size. So self size plus 1, we just increment the size. And then we have to instantiate a new node. It's going to be a node with the data. This is how we instantiate a class in Python. And if not self.head, which means that basically this head is a null, it means that it's going to be the first item in the linked list. So we just have to set the self.head to be equal to this new node. So what does it mean if not self-head? It means that this head is a null or a none in Python. Basically we know that it's going to be the first node, so we just initialize it to be the root node or the head of the linked list. And else we know that we already have the head or the root node, whatever we call it. Basically this head is the first node of the linked list. So else we set the new node dot next node to be equal to the self.head, and self.head is equal to the new node. So this is what we have been discussing, that if we would like to insert items at the beginning, we are going to insert it to be the head. It's going to point to a null or a none in Python. If we would like to insert 4, then basically it's going to be the head of the linked list, and we set this new node to point to the previous head of the linked list. So basically we just have to update the references. We would like to insert -5. We instantiate a new node. It's going to be the head, and we set the pointer to point to the previous head of the linked list, because before inserting -5, the 4 was the head of the linked list. The head is the root or the first node in the linked list. So this is why we do it. If not self-head, it means that if this is the first node, we just set the head to be equal to the new node. Anyways, we just have to update the pointers. The new node is going to point to the head, and the head is equal to the new node. So this is how we insert item at the beginning of the list. What's the type complexity? It's going to be ordo 1. Very fast. Basically, this is why we like linked lists. Okay, then how are we going to define, for example, the size? I'm just going to have a method, for example, size. It's going to return with self.size. Okay. And what's very important that we could implement the size, for example, size2 method, and it's going to iterate through basically the whole linked list and going to calculate that how many items are stored in the linked list. So we have the actual node is equal to the self.head. We have a size to be initialized to 0, and while the actual node is not a none or a null, then we just have to increment the size. So the size plus equal to 1, and we have to increment basically the actual node is equal to the actual node dot next node. Okay, so we just hop to the next node and we just return with the size. What's the difference between the two size method? That this is going to have the ordo 1 time complexity and it's going to have the ordo n linear time complexity. So it is not good. This is why we store a reference to the size, and basically this is how we initialize it to be 0, and on every insertion we just increment the size because we are able to get it in ordo 1 constant time complexity. This is going to work fine, but on every time we want to calculate the size we have to consider every single item in the linked list. Not that efficient. Okay, in the next video we are going to implement the traversal and insertion at the end. Thanks for watching.